Every day we adapt to changes in our environment and in our world. Changes occur from the moment we are born to when we develop, to when we grow, and to when we age. Today we are going to be discussing a concept that many people have heard of, and for some it could be brand new. It's called neuroplasticity, and thankfully we have Dr. Nedd here, who is going to help us break it down.
Well, thank you, Ellie.
You're welcome.
So you started this discussion by talking about change. And none of us are the same as we were yesterday. We change from moment to moment and from day to day.
Right.
And that is the key basis for neuroplasticity. It's about how our brains change to adapt to an environment around us. So if you start with the developing brain, before you're born and after you're born, the developing brain is exposed to a world of new information on a constant basis, and it has to adapt in order to grow and develop. What we learn in school, how we relate to our parents, how we relate to our society, all of those external changes in our universe, our brain must adapt to those changes. And so the physiological changes that occur in the brain that allows us to adapt is called neuroplasticity. Now, this is not only characteristics of the growing brain, it's also characteristics of the aging brain. So as the brain ages, we lose cells, we lose connections, we lose relationships. And a fact that most people may not have heard of or know about is that when we turn 90 to 100 years old, we are only left with about 10% of the neurons or the nerve cells that we were born with. So imagine how much adaptation that the brain goes through because of its redundancy and its ability to change through this process of neuroplasticity as we age, so that we could maintain who we are and who others perceive us to be. Phenomenal changes.
Yeah. So how does neuroplasticity fit in with the brain injury?
Well, when you look at neuroplasticity from an injury perspective, what actually happens is that this is what we call acquired brain injury is an accelerated form of aging, if you want to think of it that way. When aging occurs, we have a lot of time to adapt. But when injury occurs, or what we call acquired brain injury, the brain doesn't have the same amount of time to adapt. So we feel the effects more dramatically. Exactly. Right. And that's why we are left with more deficits and problems functioning. So time is an important factor on both sides, when brain is being injured and when the brain recovers. Time is an important factor. So the rate at which brain injury occurs impacts on our ability to restore.
So how does the brain use neuroplasticity to restore?
Complicated subject, but in simple terms, what actually happens in neuroplasticity is that the nerve cells in our body, which is the basic unit where all the action is, what we call the neurons. Mm-hmm. The first issue we're concerned about is how to prevent those cells from dying. And we say time is brain. And neuroplasticity is involved in that process. The next step would be, if the cells die, how do we get them to be replaced? How do we restore new cells? How do we develop or regenerate new cells? The next step in neuroplasticity is the cells that are left, how do we optimize their function? How do we get them to function better? And how do we get them to restore and reroute their connections? Underneath this process is a term called long-term potentiation. We use the abbreviation LTP. Right. And what happens is the brain learns by wiring, repeatedly using certain nerve tracts or connections over time. And with the repeated use, that's how we remember. That's how we establish a pattern. And in my book, the chapter before the last, we talked about the brain loving patterns. The brain loves patterns. And whenever patterns are damaged the brain is constantly trying to restore such patterns. Neuroplasticity is the process by which this restoration occurs.
So what is the end goal, basically?
Well, the end goal is one is within the physiology or the physiological functioning of the brain is to enhance these chemicals that encourage neuroplasticity. And there are a number of compounds, what we call neuropeptides or neurotropic factors, that are responsible for promoting proteins growth,
Likewise.
synapses, and so forth. The two main ones, one is called nerve growth factor or NGF, and the other one is brain-derived neurotropic factors, so-called BDNF. And these compounds, in science, we've discovered play an important role in certain parts of the brain, like the hippocampus, where memory occurs. Because the brain is changing constantly, and memory is one of the functions that needs neuroplasticity to take place for us to learn new things. So in the hippocampus is where you find the highest concentration of these compounds in the brain. So that allows us to restore and remember things, to rewire. The other phenomenon that occurs in the brain is that there's a lot of redundancy. This process of neuroplasticity allows us to recreate certain functions by pulling the information stored over time from different parts of the brain, such that neuroplasticity could occur.
So basically, in simple terms, neuroplasticity is all about adaptation.
Absolutely. It's about adapting to change and what the brain does to go through that process.
So, Dr. Nedd, what can be done to enhance this neuroplasticity in the brain?
Well, that's a fascinating concept in itself, and I'm glad you asked that question, because this is what allows us to rehabilitate and restore functions. First, we want to preserve this. We want to prevent a brain from being exposed to environments that are toxic, that could cause destruction of brain cells. That will also prevent us from developing these brain factors that promote healing. So certainly, drugs, excessive use of alcohol, poor diet, all of those factors. And a major one is exercise. Exercise promotes the development and the production of these neurotropic factors in the brain, like BDNF. We know that people that exercise, do yoga. In fact, in the elderly, people that continue to exercise their brain by reading and performing any of these mental tasks, these tends to promote brain plasticity. And certainly the process of rehabilitation after injury is critical in neuroplasticity.
So neuroplasticity is how you heal the brain.
Absolutely.
Awesome. Okay, well, thank you, Dr. Nedd. That's it for today.